Hi guys, in this lecture video, I'll be discussing significant figures in scientific measurements. So whenever we make a scientific measurement, it is important that we follow the rule of sigfigs, so that way we can clearly communicate whether the uncertainty exists in our measurement. And so we have to follow the rule of sigfigs, and the following are the rules for sigfigs right here in scientific measurement. And this rule is called the 1/10 rule. And the first step is to do the following. Find the smallest increment or the smallest division on the instrument. Every instrument that we use need to have some sort of scaling on it. And based on the scale, we can find the increment. For an example of some of the following example of the scaling. So in this first case right here, to identify the smallest increment on this particular ruler, we can see that the smallest increment refer to the increment from one increment to the next. And in this case right here, we can see this is 1 and that is 0. So that means in the middle it is 0.5. And each of this is then increasing by 0.25. So that's what the smallest increment on this ruler would be. So the smallest increment here is 0.25. Versus on another ruler, if this is the scaling on this ruler right here, we can see, so here's 1 and here is 0.5. So each of this is increasing by 0.5, and that's what the smallest increment would be, 0.5. Versus on this ruler right here, so here's 0 and here's 1. So each of this is then it seems that there are 10 increment in the middle. So each of this increment right here is then increasing by 0.1. And on this odd instrument right here, here is 20, here is 40. So that means in the middle it is 30. And each of this is increasing by 10. So that's what the smallest increment on this different scale from the different instrument will be. And now the next step is to take the smallest increment that we have found already on step 1 and divide it by 10. We would then obtain the answer, and we would round this answer right here to one significant figures. And then from there, we would determine how many decimal place that it has. So let's now try a few examples. If we were to now follow this rule right here, we will then take this 0.25 and divide it by 10, which then equal to 0.025. And once we have obtained this value already, we will then round this to one significant figures. So in this case, when we round this to one significant figures, it equal to 0.03. And now we pay attention to how many decimal place that this value have. So in this case right here, this answer right here that we obtain have 2 decimal place. And as for this example right here, when we take 0.5 divided by 10, we will have 0.05. And I have one sigfig on it, so we don't need to round it. And now we take notice that this value right here have 2 decimal places on it. And similarly, when we take this and divide it by 10, we have 0.01, which is one sigfig. So we do not need to round this further, and now have 2 decimal places on it. And as for this one, 10 divided by 10 equal to 1. So therefore, this value right here is rounded, should be rounded to the 1. And now here's the step number 3. Read the measurement to the same number of decimal place as the value that we identify in the step 2. So in this case right here, if we were to be using this ruler, we need all of our measurement to be reported to 2 decimal places. And similarly, if we were to use this ruler right here, we need to be reading or reporting our value to 2 decimal places, and 2 decimal places over here as well. Versus when this one, we will be reading to the 1 place. So that is how we should be reporting our value. And this method right here will then create an error of 1/10 of the smallest increment. And this is the reason why we call this the 1/10 rule. Now, let's apply and let's try a few examples and learn to apply this rule that we have learned already. So let's try now the first example A. So here in this case right here, when we follow the step and find the smallest increment. So here would be the increment right here. Here's 20 and here's 40. So that means each of this is increasing by 10. So the smallest increment equal to 10. And now when we take 10 divided by 10, we will get 1. So basically this tells us that we need to read to the 1 place. Our value need to be reported to the 1 place. And now let's try this reading. So in this case right here, the measurement is somewhere between 40 and 50, right? But we know the 40, it has to be more than 40. That's something we know for sure. So on the 40, that 10 place right there is known for certain. And in this case right here, it do not seem to be halfway between 40 and 50, but a little bit more toward the 50. So therefore, our next guess would then be 46 milliliter, or whatever the unit it may be. So in this case, an acceptable reading for this would then be 46. But we are reading to the 1 place. And that's what this meant earlier, that we need to report our value to the 1 place. And here with 46, we are reporting to the 1 place. And on this 1 place, or this digit 6, that's where the uncertainty would exist. And this uncertain digit right here can be 1 higher or 1 lower, meaning the following. If someone else were to read this as 45, and someone else were to read this as 47, all of this value right here are acceptable. So anywhere between 45 to 47 would be acceptable. And now let's try another example in here. So here is a reading on a glass cylinder. So here in this case, this is the liquid level. Now, so you would then notice the following. On this liquid level right here, it's curved around a little bit, but it's not as flat as what we have seen in this beaker. And anytime that we have equipment that have a hollow columns, then this tend to happen right here, that we will see the liquid, it curve around a little bit. And this curve right here is called the meniscus. And whenever we have instrument that form this meniscus right here, the guidelines is to do the following. Read from the bottom of the meniscus. So when we look at this curve, we don't read this anywhere. We don't read on the top part, and we don't read in the middle, but we always read from the bottom part, which is this part right here. So that's where we would use to line up with the scale and do our reading. But now let's follow the step first. First, find the smallest increment. So here is 35 and here's 40. And there's 1, 2, 3, 4, 5 increment in the middle. So that means that the smallest increment would then be 1. So smallest increment equal to 1 milliliter. And now when we take 1 divided by 10, it would then equal to 0.1. So 0.1 have 1 decimal place on it. So our reading need to be read to 1 decimal place. So that is significant to this value. So we do this calculation so that way we know to what place or decimal place that we need to report our value to. Okay, so here in this case right here, we need to report our value to the 1 decimal place. And now let's try this. So here in this case right here, so let me delete this so we can see this easily. So here is 35, here's 36, here's 37. So the value it is between 36 and 37. And it seems to be exactly in the middle between 36 and 37. So we're going to read this as 36.5. So we know it's 36 for sure. And now because it's between 36 and 37. So that's why that we are guessing or we are estimating this last digit right here. And that's why the uncertainty would exist in here. So 36.5. And because this is the estimated digit right here, we are trying our best to estimate this. And our estimate can be wrong sometime, right? So therefore, the range of what we acceptable is that this value right here can vary, whereas it can be 1 higher or 1 lower. So therefore, value anywhere between 36.4 to 36.6 all of this value right here would be acceptable. And lastly, this burette right here. So here in this case, this is also a hollow column. So we are seeing this meniscus right here, and we're supposed to read right there. Now, so if you were to actually pay attention, you would then notice the following. The scale on this burette right here is different compared to the beaker and the glass cylinder. So on the glass cylinder, we start from small value. On the cylinder and a beaker, small value go from the bottom and high value is on top, right? But with this burette right here, due to the way it is being designed, small zero actually start on top and then get higher as we get to the bottom. So we always read from low to high, right? Never high to low, but low to high. So in this case, we have to read down the following. Okay, so this would then be 20.5 here in the middle. And now again, let's follow the step. First, find the smallest increment. So you can see each of this is increasing by 0.1. Isn't that right? Because this is 20.5, so this is 20.1, 20.2, 0.3, 0.4, 0.5. So the smallest increment is actually 0.1. And now when we take 0.1 divided by 10, we'll get 0.01. And this value have 2 decimal places in it. So this tells us that our reading need to be read to 2 decimal place. And now let's read this. So in this case right here, so this is 30.3. So the value is between 30.3 and 30.4. Okay, so between 30.3 and 30.4. But it's not exactly between 30. So we know it's 30.3 for sure already. But now it's not exactly between 30.3 and 30.4, but more toward the 30.4. So this is why the next digit that will be guessed in would then be an 8. If it's exactly in the middle, it will be a 5. But in this case, it's more to the 4 than the 3. So that's why we are estimating this. Now, in this case right here, we know the volume is 30.3 for sure, right? Because we know it passed this for sure already, but we estimating this next digit right here. And because whenever we estimate something, that way its uncertainty would exist. And that's the meaning to this digit right here, 8. So in this case right here, reading that ranges anywhere between 30.37 to 30.39 would also be acceptable as well. So in this class right here, you need to be able to learn this 1/10 rule right here and make readings that will fall into the acceptable range of what we would expect. For an example, if I were to read a value, a measurement as 30.38, then I would only accept answer that ranks anywhere between 30.37 to 30.39. If you were to have value that is 30.35, then that would not be acceptable. So you have to learn and do your best to make the good estimate. And this is actually important. So the only way for us to make sure you learn and make the good estimate is for us to be picky about this. And still, there is actually a good room of errors using this method. So please try this 3-4 example right here to make sure you learn how to read this measurement.